Scripting is a valuable tool for a control systems engineer. Recently, I was asked to create a SCADA project for a PLC I'd programmed months ago. To create the tag listing, I needed the tag name, the description, and the address in memory. It can be slow, tedious, and error-prone to manually find, select, copy, and paste this information from ladder logic into a spreadsheet. Doing just one rung here took 18 clicks. Now, this is okay if you have a few dozen rungs, but what if you have hundreds or thousands of rungs to work through? Before you poke your eyes out, there's another way. You can break out of Alan Bradley's walled garden by exporting the code as XML and then let scripting take over. So to export as an XML file, you right-click on the routine and select Export Routine. We'll just leave export using the default file name. Here we have the exported XML file. The scripting language I'll be using today is Elixir, which you may not have seen before, but give it a chance, and when I'm done, I'll explain why I reach for Elixir over Python for most scripting tasks I encounter. So the first thing I want to do is open this XML file in Elixir. So in order to do that, I'll create an Elixir script file. I'll call it generate SCADA tags. Generate SCADA tags from L5x.exs. So L5x is just Alan Bradley's version of XML. It's an XML document, but for some reason they save it with a different extension. That's okay. So in order to pass an XML file in Elixir, what we're actually going to do is use a function from Erlang. So Elixir was built on Erlang, so you have access to all of Erlang's standard libraries. So the function we're going to use today is part of this XML scan module, and the function we want to use is this file function. So all we have to do is we have to pass in a file name, and then the result will be an XML element and the rest. So it should return this tuple if we're successful. So let's have a turn at that. So if we call XML scan.file, and we pass in the name, this file name here, so I'll just copy it. And then what we want to do is we want to print the result to the screen. So in Elixir, you use the IOInspect function. Now this symbol here is the pipe operator. So the result of this first function gets piped into the first argument of this IOInspect function. So when I save this, it will automatically run and we'll see our result down here. So it looks like it's succeeded. We didn't get any errors. So the next thing I want to do is, if you remember from the documentation, this function returns some XML and some other metadata. So what I'll do is use Elixir's pattern matching syntax to say we'll use the XML part, but we don't care about the rest. So the result of this function will be deconstructed into this tuple here. So if we run that, we should get the same result, which we do. The next thing I want to do is go through the parsed XML document and find the rungs. So if we look at this, if we just search for this tag here, it appears in two places. Up here, it appears as part of the tag list, and down here, we have it as a rung. So if we look at this XML document, XML, so I'll just save this quickly to get it to format nicely. XML is just a tree. So if we look at it, the trunk of the tree, if you like, is this RS Logics 5000 content. Then we go into the controller part of it, we go into the programs part, the program, then we want to go into the routines, one particular routine, we want to look at the relay ladder logic content, and then we want to look at the specific rungs. So the way you do that is using XML XPath. So what we'll do, XML XPath string. So if we're looking for the rungs, we need to travel along the tree. So RS Logics 5000 content. Then we want to go down to the controller, programs, program, routines, routine, RLL content, rung, text, and we want the text element. So text, and we need to tell it that it needs to look in this XML document. So what we'll do is we'll move this IOInspect to after this function, and we'll see what our result is. Okay, excellent. So the result of this XPath query is a series of rung elements. So we've got a list here, and so each element has a bit of data, but it also has a logic as a text string. So what I want to do is essentially do an operation over each of these elements of this list and return just the text string. So the way to do that in Elixir is to pipe the result into a map. The map is part of the enum module. And so this list will be passed into the first element, so it needs an enumerable, and then it applies a function to each element. So the way we'll do that is function, and then so for each element x, what we want to do is we want to do a pattern match on X. So we want, basically each element has this structure. So what I'm going to do is copy an example, paste it in here, and we want that to equal X. So what we want to do is look at this and say, all right, we don't care about the first element, so we'll just use an underscore there, and then this next list we don't care about. Then this integer here we don't care about. This empty array we don't care about. This string, this is what we're after really, so we'll call this the rung. And then this last part here we don't care about. And then what we want to return is just that rung value. So if we save that, the result is exactly what we're after, just a list of those rungs. So if you remember, the first rung was this no-op, which we don't really care about. So if we go and have a look in the logic, this first no-op here, we don't care about. We sort of skipped that. And then we're interested in all of these rungs, except for this one here, number 13. That's an AFI, so it will never get executed, so we don't care about this rung either. So what we want to do with our result here is filter out this first element and this element down here with the AFI in it. So the first thing we need to do is make sure that our rungs returned are actually formatted as strings. So I'll apply the toString function. So if we run that, we should get the same result. Yep. Then what we want to do to each element of this array is we want to check whether it contains no-op or AFI. So what we're going to do is enum, and I'm going to apply a filter. And our filter's similar to map, so we just need to supply a function. And what we want to check in each element is we want to check that the element does not contain no-op or AFI. So not string contains no-op or AFI. Okay, let's run that. Okay, great. So now we only have the rungs that we're interested in. The next step is to split each of these elements up into the parts we want. So we're not really interested in this segment here. What we want is the tag name. We're not really interested in this segment, and we want the address. So what we can actually do is split on these open and close brackets to break the array up. So we'll do another map. And we want to do a string split. So we want to split it up on open or closed brackets. So if we do an open bracket, actually that will work. So an open bracket or a closed bracket. Let's run that. Okay, excellent. So here we have the result we're expecting. So what we're going to do is use pattern matching again to only get the segments we care about. So we don't care about this first part. We want the tag name, so we'll just call that one tag. We don't care about that. We care about the address, and we don't care about the end segment. So what we'll return at the bottom is just the tag and the address. Excellent, now we have what we're interested in. So the next thing to do is we need to get the description from the XML document. So when we looked up this tag, we saw that it was used in the rungs, but it was also used up here, part of the tag. So we need to go to RS Logix 5000 content, controller, tags, tag, and then we need to look for one with a particular name. And when we find that, we need to retrieve its description. So the way to do that with the XPath syntax is similar to what we did above. So I'll just demonstrate that here. XML. Sorry. XML. String. No, path. XPath. XPath dot string. Now the path we're looking for is RS Logix 5000 content controller tags tag. Now we're looking for a tag with a specific name. I'm going to use string interpolation here to put our name in. And then we want its description. And we want the text from that description. And we're going to be using that XML document again. And what we'll do is return those results. So I'll just comment that rung out for now, and we'll see whether this works. Okay, we've got a match error. Okay, I think we have missed a bracket somewhere. Yep, that name there's that's the open bracket, that's the closed bracket. So let's give that another go. Okay, excellent. So the result looks like this. So what we're going to do is pattern match again. So we'll say equals, put our result in. So what do we care about here? We don't care about this first segment, so we can discard that. We don't care about this second segment, we can get rid of that. We don't care about this integer. We don't care about this empty list. We care about this description. And we don't care about this element. If we return just the tag description now to see what it looks like. And run the code. You see, we've got some new line characters which we want to get rid of. So the easiest way to sort that out is using string split again. And we want to split on the new line character. Run that. Okay, so we're getting an error. It's missing a close bracket terminator, so we'll add that in. Okay, we're getting another error saying the result is in binary. So what we actually have to do is call a toString to convert this tag description into a string. Okay, there we go. That's exactly what we want. So what we can do is pattern match and get the middle part out. We'll copy that and we'll paste it in here. And we don't care about the first part. We care about the tag description. We don't care about the second part. So essentially what we've got now is what we need. We've got our tag description, and our address. So we'll try and return that, see what we get out. Okay, that's exactly what we want. The only thing left to do is to format it correctly. So we've got an array of arrays here, but what we want is an array of strings, and then we'll write that to a file. So the way to do that is, rather than returning this array, what we'll do is we'll return a string. So we'll replace that with a string start and string end. Now we need to do string interpolation in here, so close it with the brackets. So return that. Okay, that's looking better. I did forget to put a new line character at the end, so what I will do is add that in now. That format looks good. Then what we can do is we can do a file write. So this is looking for a path, so we'll just give it a name. We'll call it tags.csv. It's looking for content. So that's the result of this whole calculation up here. I don't think, so what we can do is give it a name. I'll just call it data. So we'll return data. So if we run that, we can see over here we've generated a tag.csv file. And here we have the information formatted in a friendly format to be imported into our SCADA system. So there you have it. We've completed our task. The final thing I wanted to do was discuss why I reach for Elixir over Python for simple scripting tasks. Now, I love Python, it's a great language, but there are some things in Elixir that just match the way I think better. The first thing I like is this pattern matching syntax, how we can deconstruct our result and only pick out the part we like. The next thing I love is the pipe operator. I love the fact that you really get the feel that you start with data, you apply a series of transformations to that data until you get it in the format that you want, and then you're done. I also like with the piping syntax, you don't have to agonize over naming intermediate steps of the operation. So in Python, each function you call, you'd be giving it a largely meaningless name. You'd be trying to choose meaningful names, but if you have to do a lot of transformations or a lot of operations, it's hard to think of names that mean something to you but also mean something to the next person. So in Elixir, why bother? You just pipe the result from one operation into the next. So it saves you that mental overhead of having to choose names. I also really like the Elixir documentation. That Erlang documentation I showed earlier is really easy to follow, but so is the Elixir documentation. If you come over here, you can click to view on hex docs, and I'll just open the link. The hex docs documentation is fantastic. Let me just zoom in a little bit so we can see it a bit better. Oh, a little bit too far perhaps. But if we look at the filter example here, it really breaks down how to apply the function, and it's really easy to search. It's really easy to look at other options you have to achieve the result you're after. I hope you enjoyed this worked example and found it useful. Next time I'm planning on generating some ladder logic using Elixir and contrasting that to generating the same logic using Excel. So until next time, take care.